Now here are a few extra problems. There's a longer version of this where I give you some discussion and so forth, but just going to present them very briefly. We want to geometrically construct a graph representing y equals f of x equals x to the p for y factor 5 halves. Recall that you did this for factor 3 halves. We did this in preceding videos. The graph should extend from the lower left to the upper right of a nice rectangular graph window. Okay, so here's an example of a nice rectangular graph window. That's what I mean by that. It's not long and skinny. It's not tall and skinny. It's not too skinny. It could be, of course, as fat as it could get would be a square. It could be a square, but generally we make it a little wider than it is high or a little higher than it is wide in order to best see the trend of the curve, see any curvature and so forth. If we make it too narrow, the graph is flat, either this way or this way. Okay, so, and then we're going to mark a point 1, 1. I've drawn a purple curve here. Obviously, that's not what your graph is going to look like. This would be a graph of some kind of a parametric equation, most likely. And it's not a function, obviously, doesn't satisfy the vertical line test. Okay, anyhow, so we mark the point 1, 1 on a curve near the right, on the curve near the right boundary. So right boundary is over here, so we mark 1, 1 here. And of course we're going to mark our point 0, 0, and that's probably going to be near the left boundary. Then, having constructed the graph, we estimate f of 1/4, f of 1/2, f of 3/4, and solutions of the equations f of x equals 1/4, f of x equals 1/2, f of x equals 3/4. If you don't know what all that means, you might want to look at the longer versions of some of the earlier videos. Okay, then using the 1, 1 point on the same set of axes, using the same 1, 1 point, the same point you marked here, construct the graph of the factor 3 halves power function. Okay, well, we already constructed that. You know how to construct it. You have most of what you need in order to construct it. Now, I emphasize throughout here, we aren't measuring anything, we aren't calculating anything. We're doing all this by eyeball, by estimation, and by, of course, I encourage, but don't require, compass and straight edge constructions, which can take you through a whole lot of this process. Whether you use compass and straight edge or not, though, you should be able to estimate what you would get if you used a compass and straight edge. Okay, now we're going to call this 3 halves factor function g of x, and we want to estimate g at 1/4, 1/2, 3/4. Then we want to estimate f of 1/4 over g of 1/4, f of 1/2 over g of 1/2, f of 3/4 over g of 3/4. You should think about what that means. You go back to the longer video and see, but you should, and see what I mean by this little figure here, but I'm not going to discuss that here. Then, for x between 0 and 1, what can you say about f of x over g of x is a simple statement you can make. And about the trend of these values as you go from x equals 0 to x equals 1, what's the trend of those values? Then, what's going to happen to f of x over g of x and the trend for x greater than 1? And can you prove that that would actually be the case?